Let's look at the givens in this problem. We have a piece of aluminum starting at 0, so this is T1 for the aluminum. And then we have a volume of water, and we know that this can be used for the mass of water. And then we have the water cooling, so this is T1 for the water and T2 for the water. And we know that the T2 for the water is going to be the same as the T2 for the aluminum because heat will be transferred until the temperatures are equal. Okay, so when we think of this equation, which is our equation when we're dealing with things heating and cooling, if we look at all of the numbers we have given, we have all of these numbers for the water. So we can solve for Q for the water using all of the numbers for the water. So Q, specific heat of water, is given. Mass of water, really that only has 3 sig figs because the density only has 3 sig figs, but it won't end up mattering anyway. And then T2 for the water, T1 for the water, okay, and as usual we want to watch this step right here because sometimes that really causes our number of significant figures to drop, which it did in this case. And we need to keep track that really only has 2 sig figs, so we'll use 2 as we go on, but even though I use the same, I'll use all the digits. Okay, and then we know that for the metal, we're going to have the same number but opposite sign as the Q for the water. So in other words, we're going to change it to a positive. And then we can set up this equation for aluminum. And so plugging in, the specific heat for the metal was given, the aluminum was given. We're solving for the mass of the aluminum this time. Okay, and then we'll watch this to make sure on the sig figs, and it's fine, it still has 3. So then dividing everything by what's on this side. And I get a mass of my aluminum is, to 2 significant figures, it comes out 4.3 times 10 to the second